Okay, chapter 11. Now, chapter 11, there's a very important part is graph the parabola, quadratic function, and then find the minimum, maximum, and how to find the symmetric line. Now, those type of skill, not too hard, so I show all the work on the classwork PDF file. So you can take a look, and when you do the homework, you can practice with that. Now, because graph the parabola is not that hard, so I would like to use this opportunity and extend the concept for to prepare for chapter 12, chapter 13, because we have more complicated graph on chapter 12 and chapter 13. And the new concept from chapter 11, we call this transformation. Transformation. So the idea of the transformation is because the vertex of the parabola not always at the 0, 0. It may be here, maybe upside down, maybe somewhere here. Okay. Now, it's not too hard to graph the parabola, but when we comes to chapter 12, chapter 13, let me show you. Okay. So we will do a lot of practice on chapter 11 parabola. And in the same time, we want to learn the concept for the formula for the graph. How can we easily graph when you have chapter 12 exponential function? Exponential function, the graph is more complicated, involve asymptote. And what's our HK looks like a little different. So there will be two important things you have to learn is by using chapter 11 easier example. We want to learn number one, how to make a transformation, and you want to find the important coordinate HK. Now HK somewhere in chapter 12 we don't have HK, but the kind of idea of HK. Now that's the first concept. Second concept is you will see y equals to something plus k at x minus h. So you can see x minus h and somewhere you plus k. Now, when you go to next chapter, chapter 13, you are going to see that y minus k, x minus h. So when we supposed to plus k, when we supposed to minus k, that's interesting concept you want to learn. And I can just tell you right now easily. Because if you move this k to the other side of the equal sign, you minus k on both sides, then you have y minus k. So plus k or minus k basically depends on if k is close to y, then it's minus. When h is close to x, then it's minus. So basically, hk is the number x and y minus, x minus h, y minus k. So when you move k minus k to the other side of the equal sign, then it becomes plus k. So this is the very easy concept, but the very confusing part students may ask all the time. So I will roughly talk about the idea, what we want to concentrate to learn these two things, and the more detail I will explain more. If you don't quite understand plus k minus k yet, that's okay, because I just want to tell you what we should learn here from this video. Okay, let me erase. Okay, so the formula, you have y equals to something plus k, basically is the idea of y minus k. So same thing here. We go back to our chapter 11 parabola. So chapter 11 parabola, we are talking about y equals to x squared, and then we try to graph. How to graph? Again, I say it's easy. I will graph for you and show you how to graph easily. Now, we are going to have more complicated function for quadratic function, and in the end, we need to deal with h and k. So we have h and k. Again, the number x minus y is h, so h is y. And the number y minus, so if you minus 3 on both sides, then you have y minus 3. So the number y minus is k. So therefore, when you have plus k on the function, then don't change the sign. But the number x minus 1, you need to change minus 1 to positive 1. So how you find the vertex? It's a little confusing to learn, but you may, for now, you just memorize. What's the vertex? The number x minus inside the perfect square is 1. And the whole thing, the function plus 2, 3, don't change the sign. K is positive 3. So in this case, later on we are going to graph with the red color, and we try to graph. This blue color is not the right graph. This blue color is the graph for parents graph. So why parents graph is important? This is y equals to x squared. And we memorize this graph, and after we find our vertex, then we shift our vertex to a new location, 1, 3. 1, 3 is here. And we understand our graph should something look like a parabola here. But how narrow, how wide to open, this depends on this number A. So we are going to talk about more detail for how to graph. But again, I say how to graph is very easy. So I would like you to focus on something harder is h and k, plus minus, something like that. Okay, so if I give you a complete square form, can you tell me what's the hk, the vertex, right away? That's the important thing, because once you find the vertex, basically you can find the maximum or minimum y value. So I'm going to keep going, talk about more concept. So let's go back to the first page. Okay, so I have graphed the parents graph for you. We call this basic graph or parents graph. Or we say basic. And when the function become more and more complicated, the graph should look like a parabola, just bigger size or smaller size or narrow down or more wide or tall. Okay, so we want to learn the concept, not just graph. Now, one more concept is for the first graph, we may plug in many points. So as many points as possible and connect. So we plot the point. For the first graph. And later on, we don't want to always plot a point for the graph. Why? Because, say, pretend if our graph is here. And if you try to find many points, like here, if you try to find 1, 2, 3, 4, 5, x is 1, 2, 3, 4, 5, for example, here. 1, 2, 3, 4, 5. What do you can find? If you keep going extend, you may just find the graph here, right? And what's the most important point you need to find? Basically, is the vertex. Basically, is the vertex. So if you try only plot the point, so plot point to graph without finding the vertex, you are not going to graph the whole complete parabola. Therefore, this video, you need to learn how to find the vertex. After you can find vertex, then you have all the information you need. Okay, so let me erase this. Okay, so for the easiest graph or the basic graph, parent graph, we can easily find the vertex. How we find the vertex? The perfect square need to be 0. That's the minimum. So how to find the minimum? Or if you talk about minimum, then you need to talk about maximum, right? From this graph, there's no maximum, only minimum. And the minimum value happens when you have vertex. Why you have vertex? Because on the right-hand side of the vertex, keep going up. On the left-hand side of the vertex, also keep going up. Why? Because the minimum value for the perfect square is 0. If you have 1 inside the perfect square, it's greater than 1. If you have -1 inside the perfect square, also greater than 1. So nothing below 0. So the lowest possible y value. So when we talk about minimum, maximum, we are talking about the y value. Now, when the graph is going up, why is going up? Because you have the leading coefficient is 1 here. Therefore, everything is positive. So you have upward parabola. And the minimum value is 0. And also we want to learn one more thing is the symmetrical line. It's like a mirror. So all over the chapter 11, you are not only asked to graph parabola, you also need to find out what's the maximum, minimum, and what's the symmetrical line. The symmetrical line basically goes through x equals to the vertex. So finding the HK vertex is very important. So symmetrical line, basically x equals to h. When I ask you to write down the equation of the symmetrical line, don't tell me h, because h is a number, not a line. With a line, you need to have x equals to for the vertical line. And the maximum minimum value, k, is y value. So this is my first page. You should memorize this basic graph. And after you memorize this basic graph, then we can make our graph more complicated. We say shifting. We may shift our graph left, right. Shift, left, right. Shift, left, right is when you have x plus 1 or x minus 1. Now you say, teacher, x should minus something. Yes, you can say this is x minus what? X minus -1. Okay, so when you have x minus -1, how can you graph? And where is the vertex? Again, I don't want you to choose some point and connect, because you don't know where is the most important position, which is where is vertex, right? So again, we try to find the vertex. Now, the perfect square for the function y value, this y value, the smallest possible value is 0. So we make x plus 1 equals to 0. X plus 1 equals to 0, x equals to -1. Therefore, the vertex vertex HK, this h is -1. So that's why I say the number x minus is h. Why? Because perfect square, when you solve for perfect square, this plus 1 become -1. So here we have x equals to -1. And when x equals to -1, what happened to the y value? We plug in -1. So when x is -1, and then plus 1, what happened? 0. Yes, we know it's 0 in this case. So 0, 0, -1, 0. So this is a new vertex for our function. Now, in my class, I will ask you to graph with 3 points. One vertex. So you have xy, and the vertex -1, 0. And what's other point you need? So I will say +1, -1. Okay, for you +1, you have 0. 0 plus 1 is 1. 1 square is 1. For you have -2. -2 plus 1 is -1. -1 square is also 1. So you have 0, 1, -2, 1, and 0, 1. So you connect. On the test, that's all I want. Okay. So this goes to number 2. So similar. Let me choose other color. Let me choose green color for number 2. Okay. So vertex, you try x minus 1 equal to 0. So x equals to 1. Or you can just think about the formula. The number x minus is 1. So h equals to 1. And when h equals to 1, in this case, y is 0. So you have 1, 0 for the vertex. And the same thing, you plus 1 minus 1 is 1, 0, right? Okay. So 2 minus 1 is 1. 1 square is 1. Symmetric. 1, 2, 1 here. So I have 2, 1 and the 0, 1. Okay, so I connect with the parabola shape. Don't make it a straight line, okay? I pretend you understand, so you don't need a 5 point. On the book, they ask for 5 points. But since we understand the concept of the basic function, then we only need a 3 point and connect with curve. Don't connect 3 points with straight line. Then we call this absolute value. Absolute value function. Okay. So this is the how you find the vertex. First, the page examples, and the next examples here. How about I plus k here, and this minus k means, for example, if you have some number, let me put some number here to make it easier to understand. So this is 3 plus 3 minus 3. So if you have perfect square x squared, so x squared equals to 0, x will be 0. So when x is 0, 0 plus 3, y value is 3. Then we can have, I should use green color or red color. Let me use red color this case. So we have 0, 3 for the vertex. 0, 3, 1, 2, 3. So you can see that our vertex is going up, and the whole graph supposed to be pushed up, because what? The whole graph plus 3. Plus 3 means plus to the whole y value, and then it's going up. 1, negative 1. So 1 plus 3 is 4. Negative 1 square still 1 plus 3 is 4. So you have 1, 4, negative 1, 4, and the connect. So the whole graph push up, mean pushing up, right? So you should label 1, 4, 0, 3, negative 1, 4. So when you have plus 3, the whole graph being pushed up. Understandable, when you have minus 3, the whole graph will be pulled down. So let me use green color. And when perfect square is 0, you have negative 3. 0, negative 3. Okay. And we make a chart. 0, negative 3. And we have 1, negative 1. 1 minus 3, negative 2, negative 2. So here 1, -2, -1, -2, and you have the same similar graph, just being pushed down 3 steps. So basically, the h is 0. K in this case is 3. H is 0, K is -3. So basically, K is telling you this graph need to be pushed up or pushed down. So that's K, H. So I would like to go back to earlier when the x plus or minus. When x plus, it means -1. -1 means this graph means, oh, let me change color. This graph need to be pushed to the hand side, -1, right? And when x -1 means h is +1. When h is +1, this graph being pushed to right hand side 1 steps. So after you find h, when h is +1, it's going to right hand side. When h is -1, then it's going. We say shift. The graph means shift to right hand side when h is +1. The graph means shift to left hand side. When you +1 means h is -1. You shift to left hand side. So that's the shifting idea. This idea, you may say, teacher, I just graph for you. Why you talk about so much concept? The shift to left and the h is positive is shift to right. When you go to chapter 12, chapter 13, and eventually you go to pre-calculus, we have trigonometry. All those materials, you need to graph with concept. We no longer can just simply graph with 3 points. No matter 3 points or 5 points for parabola, it's too easy to graph compared to the coming chapters. Okay, so right now let me erase those many marks here, and I would like to introduce one more concept for you to easy to understand. Why we shift left, shift right. The shifting concept. Okay, so for a function f input, we may consider this input is the work hour. You work how many hours? And the output y is the earning. You work how many hours? And according to your manager, the manager will pay you. So if you say y equals to x squared, that's a blue color, right? Let me change it to blue color. So y equals to x squared is the blue color. That's the original. If you work 1 hour, you earn $1. If you work for 2 hours, 2 square, you earn $4. So pretty obvious. Now, how about if you change the manager? Okay, and your manager say y equals to x plus 1 square. Okay, now x plus 1 square, why the graph will shift to left hand side? Because you have very nice manager. Even though you don't work, you work for 0 hours, you still earn 1 hour. You earn 1 hour income. Okay, so before on the blue color, if you work for 0 hours, you earn nothing. But right now, you work for 0 hour, you earn what? On the red graph, you earn $1 already. Okay, so you work this hour, but you are going to earn the same graph, same y value, same height. You are going to have same height, but you work this hour. If you work this hour, your graph will be shifted to left hand side. Now on the right hand side, let me change it to green color. The work hour y equals to x minus 1 squared. Wow, then your graph need to shift to right hand side. Why? Because you need to work harder. When you work 1 hour, your manager consider you didn't work at all. So in order to earn the same level of the income, for the same income, you need to work harder. You need to work 1 more hour in order to earn the same level of the income. Okay, so in order to keep the same y value, you need to work harder. So for the same y value, the whole graph shift to right hand side because you need to work 1 more hour. So you work more. Therefore, your graph shift to right hand side. So that's the idea. You can understand why the graph means shift to right hand side or left hand side. And I have been talking about two different concepts for you to understand. So you can choose either way to understand the shifting. And the push up, push down is easy to understand because after you work and then you push up, you plus more, minus. And the minus 3 is probably penalty or something, right? So this plus k minus k is not too hard to understand. Now, next will be easier. We just do some practice, okay? When you have some number multiplied to x squared, it's not a plus minus, it's multiply. Multiply with a positive number, say y equal to 3x squared or y equals to negative 3x squared. Or simply we don't want to have 3 here. We just, if you have y equals to x squared, then this is okay, y equal to x squared. And then when we talk about y equals to negative x squared, for the same x input, the y value become negative. So do you believe it's going to be going down? The graph need to going down here. This way. So just upside down. Upside down. Okay. So you have a negative compared with positive. So here, when you have upward, you have minimum y. When you have downward, then you have maximum y value. And the y value is k, okay? K value. We are going to have more example coming. Oh, sorry. I need to. Wow, my screen kind of. Okay. So since my screen kind of goes to other page, I will end the first part of the video, and then I will have second video keep going. Okay, so see you next time. Bye bye.